In this video, you are going to see about the volumetric strain, that is the stress acting on the rectangular body in single dimension and stress acting on the rectangular body in the three dimensions. So what is volumetric strain? When a body is subjected to a single force or a system of forces, it undergoes some change in dimensions. This change in dimensions will cause the change in volume of the body. So the ratio of change in volume to the original volume is called volumetric strain. So epsilon V is equal to del V by V. Del V is change in volume, V is the original volume. So the volumetric strain of a rectangular body subjected to a single axial force. So the rectangular body of length L, breadth B and thickness T is taken, and the load of the tensile force of P is acting in the one direction, and E is the modulus of elasticity of the material, and 1 by m is the Poisson's ratio of the material. So we know that del L is equal to PL by AE. So the area of the rectangular bar is B into T. So we can write del L is equal to PL by BTE. That linear stress is equal to load by area. So here area is equal to B into T, breadth into thickness. Therefore the linear strain epsilon is equal to sigma by E. Sigma is nothing but P by BT E comes. So epsilon is equal to P by BTE. Similarly, lateral strain for del B is equal to 1 by m into linear strain. So del B is equal to P by MB TE. Similarly, change in thickness del T, the lateral direction. Del T is equal to T into 1 by m into PBTE. So del T is equal to P by MBE. Similarly, change in breadth del B is equal to B into 1 by m into P by BTE. So del B is equal to P by MTE. So after the application of the load, the thickness changes and the breadth changes. That is, the length will be increased and breadth and thickness will be reduced. So the final thickness will be T minus del T, and final breadth is equal to B minus del B. So we know the volume of the body is length into breadth into thickness. So the final volume will be del L plus L into del B minus B into del T minus T. Here the minus is representing the reducing dimension. So here the breadth is reduced and thickness is reduced. So we are putting minus. So on solving this, we will be getting LB into T into 1 plus del L by L minus del B by B minus del T by T. So other small variables are ignored because the del L by L is also a very less value. When you multiply del L by L into del B by B, it will come very less value. So all the less values are ignored. The final volume is taken as this. So the change in volume is equal to final volume minus initial volume. So we know the volume of the body is length into breadth into thickness. The final volume is del L plus L into del B minus B into del T minus T. So the change in volume, we can write del L plus L into del B minus B into del T minus T minus L into B into T. So the change in volume is LB into T into 1 plus del L by L minus del B by B minus del T by T minus LBT. So on solving this, we will be getting V into P by BTE into 1 minus 1 by m minus 1 by m, that is equal to V by P by BTE into 1 minus 2 by m. So the volumetric strain is del V by V. So del V already we know the equation, V into P by BTE into 1 minus 2 by m divided by V. So on solving this, we will be getting P by BTE into 1 minus 2 by m. So P by BTE is nothing but the strain. So we can equate del V by V, sorry, epsilon B by V is equal to epsilon, this is nothing but the strain, into 1 minus 2 by m. So the volumetric strain of the rectangular body subjected to three mutually perpendicular forces. In the previous section, we have seen rectangular body subjected to a single force in the x direction. Here, three forces are acting mutually perpendicular to each other in x-axis, y-axis and z-axis. So the tensile stress acting in the x-x direction will be sigma x, and y direction will be sigma y, and z direction will be sigma z. So we know that Young's modulus of the material is stress by strain, that is E. So from this we can equate the strain in the x-x direction due to the stress equal to epsilon x equal to sigma x by E. Similarly, strain in y direction due to the stress sigma y equal to epsilon y equal to sigma y by E. And similarly in z direction we can take epsilon z is equal to sigma z by E. So this E is nothing but the Young's modulus of the material. So the resulting strain in the three directions is founded by the principle of superposition. That is, we can add all the strains in x-axis, y-axis and z-axis. If the strain is positive, we can take it as positive. Sorry, it is when the strain is tensile, we can take it as positive. When the strain is negative, it is for the compressive strain. So epsilon x equal to sigma x by E minus sigma y by m into E minus sigma z by m into E. So this 1 by m, it is representing the Poisson's ratio, and on solving it we can get epsilon x equal to 1 by E into sigma x minus sigma y by m minus sigma z by m. Similarly, for y direction we can write epsilon y is equal to 1 by E into sigma y minus sigma x by m minus sigma z by m. For z direction, epsilon z is equal to 1 by E into sigma z minus sigma x by m minus sigma y by m. So here the volumetric strain is the sum of all the strains in the x-axis, y-axis and z-axis. So volumetric strain del V by V we can write as epsilon x plus epsilon y plus epsilon z. So this positive strain is for tensile stress and negative is for compressive stress. So in this session we have seen the volumetric strain of the rectangular body under two different conditions. One is subjected to a single force, and second condition subjected to three mutual perpendicular forces. Thank you.